we were looking at, we looked at a introduction to window functions, right? We know how it looks like. And we also saw what is CTE, right? So let's write it down. So we said you can think of it like we are selecting, right? So we can say select some columns from the table, right? Column 1, column 2, column 3 from the table. Then we can have any of the group functions here. So I can have max of something, min of something, sum, count. Then what do we want? Average and standard deviation. Right. So these are the 6 group functions you can use over the window, right? So inside the window, what you can have is you can have partition by and order by, right? So partition by some column. There is no comma or anything, right? It may or may not be followed by order by some column, right? So this is the window. Okay. So this is what we call the window. So from this, we can select any of these functions, right? So like this, you can have many windows and you can say from your table name, right? So my table or something. So this is how your window function, the simplest window function would look like. So in addition to this, there are certain functions which are specifically meant to be used as window functions, right? So these can be used anywhere, even without a window, but there are certain functions which can be used only over this. So you have what is called the rank. You have dense rank and row number. And then you have lead and lag, right? So these are the most commonly used window functions. There are other things like a first value, nth value and all, which I don't find very useful, right? And there again, we have to define a frame and all, right? So that we won't see. We will focus on these, right? So these are the most commonly used functions. So these are what you can use over some window, right? In addition, so when you write a query like this, one thing that we cannot use is we cannot use this thing, whatever you are selecting here, right? So we are selecting max over partition by something. This will give you some number, right? So for example, if you're selecting max of salary over partition by department or something, right? So whatever value you get here, this you cannot use in the where clause, right? So this window thing cannot be part of the where clause. It can be only used along with the select. So when you want to select based on what you get here, those are the cases where you have to actually go for a CTE, right? So without that, you will not be able to write it. So let's see some examples here, right? So yesterday we did see a couple of examples, but yeah, let's see some examples here, right? And then we will move on to rank, dense rank, and row number, and lead and lag. Okay, but this is the format. And CT, if you remember how we do that is with some alias name, right? So E or CT as, then you write your select command, select this thing, right? With CT as this, select CT dot column 1, CT dot column 2, and so on, right, from CT. So this is how you can write your common table expression. So these two together will help you to create some good, write some queries, right, which are otherwise not possible. Okay, so this is, you can keep this as a reference. Okay, so now let us take our product table, right? If you see, there is a table called products. We have already used that. Select star from products. Let me limit it to some 20 records. So here we have what is called a MRP, right? So MRP is the price of each product. And then you have something called the product line. So what is product line? You can think of this as a category, right? So these are all categories of classic cars, right? So these are all categories of motorcycles, right? So what, let's say what I want to find is which products I'll give you the question, right? You think about it and tell me how you can do that. Which products cost more than the average price in that category? In average price in a given category or in each category, let us say, right? Which products cost more than the average price in each category? So what this means is, so if you look at classic cars, right, and you take the average price of classic cars, let's say the average price happens to be 130, right? So which are the products which cost more than 130 in the classic cars category? Similarly, if you look at motorcycles, these are the motorcycles which cost above average price, right? Are you clear about the question? What we want to find? We want to, what is the average price of each group? And then which are the products which cost more than that? Right, so these motorcycles are above average price for the motorcycle category, trucks and buses and so on. Will you be able to write this? Or you tell me how you will go about it? What should we do? First, we have to group it based on the category. Right, so we will group all classic cars together. Then we will group all motorcycles together, right? Then we will group all trucks and what is that, buses together, right? And then what we can do, once we group this, we can find the average salary. Sorry, average MRP. What is the average MRP of classic cars? What is the average MRP of, what is that, motorcycles? What is the average MRP of this? How do we do this?
Using window function?
Using window functions. but we have to first group it, right? We are grouping the records based on the product line, right? And for each product, we have to find the average price. After that, okay, let us write this first. Do you agree this is what we have to do first?
Yes.
Right. So let us write it using a window function, right? So I will say select star, right, comma, average of MRP, right, over, what should I write here? What should I write? What do we want within the window?
Partition by product line.
Partition by product line.
Yeah. Partition by product line. Okay. As average price from products, right? And let us limit it to some 20 records. Okay. So now, once we have done this, then it becomes easy to find those products which have more MRP. So assuming that if you have a table like this, right, wouldn't it be easy to find which all products have more than average price? Assume that you have a table like this, right? So all I have to do is select star from this table where MRP is greater than this one, right?
Yes, ma'am.
So here I have only classic cars, but there will be other products also, right? So assume that you have a table like this, or let me not limit it to 20. Let's look at all the products. Yeah. So if you look at this vintage cars, the average price of vintage cars is 87. So now I just need to find all vintage cars where the MRP is greater than this, right? So obviously this is below average. This is below average. This is above average. This is below average, right? So if I have a table like this, then from this table, I can select all records where MRP is greater than average price, right? So now we can write this as a CTE. We will select star from this select where MRP greater than average price. That's all, right? So if you remember the syntax for writing CTE, we can say with CTE or E or some alias name, right? Let me call it CTE as this select, right? From this select star from CTE where CTE.MRP is greater than CTE.average price, right? It happened. Select star comma CTS. Okay, let us try. Why is that doing an error? Okay, let us see. Select star from where E dot MRP greater than E dot average price. Let's try this, but why did the other one not work? Okay. So we had in products table, we had around 110 records, right? Out of those 110 records, there are 56 products which actually cost more than the average price in that particular category, right? If you see here in classic cars, we have got all the, whereas until here, yeah. So all the records that we have here have a price greater than the average price of classic cars, right? And if you look at motorcycles, these are the motorcycles which cost more than the average price of the motorcycles, right? Can you try this? Meanwhile, let me see why this didn't work. Oh, I forgot the bracket. Okay. Yeah. Right. And thanks, Rani. So I'd missed the bracket here. Right. Okay. Arshali says done. What I want you to find is, you write this, right? Find the first name, last name, job, department, and salary of the person or of the employee who gets the maximum salary in each department. In each department. I want to know that in department 10, John is the guy who's a manager, whose salary is 43,000, who's getting the maximum salary, right? In department 20, Mary, who's a programmer, gets the maximum salary. In department 30, somebody else gets it. Can you write this? Not Rani, Vishali, I think. Select. One copy from here. Okay, what did you write? Select first name
Last name.
and job, I think, job ID, department ID, salary, and you had written max of salary over partition by department ID as max sal from my EMP and limited to some 20 records. Right, so this is what you had written. And let's see. All of you have written the first step, right? But now what do we want? We want the person who's getting the maximum salary, right? So in department 1, there is only one person. So he obviously gets the maximum salary. How about department 20? Maximum salary is 13,000, right? Who gets 13,000 as the salary? This person. Then coming to department 30, the maximum salary is so much. Who's getting the maximum salary? This person. Department 40, there is only one person. In department 50, who gets the highest salary? This guy. That is what we want. We want Jennifer, Michael, Den, Adam. So these are the records that we want. We don't want so many records in each group. How can we get that? Assume this to be a table called E. Then you will select all records from table E, where salary is equal to maximum salary. Right? That's what we want. If you have a table like this, from this table, we will select those people whose salary is the same as maximum salary. Right?
Yes.
So that is the next step that you need to do. So treat this as E, right? Let me copy. With E has, don't forget the bracket, EMP, right? Select star from E, where E dot salary is equal to E dot max underscore. Okay, so we have 11 rows, and in each department, these are the people who are getting the maximum salary in their own department. Okay, so think of it, you visualize it in 2 steps, right? So sometimes, and then use CTE to get what you want, right? Okay, so this is how you can use these functions, these group functions, right? So min, maximum, sum, count, right? So count you can also use. Remember where we had found the products which had more than the average MRP, right? So instead of finding the names, right? So let us say you might be asked to find how many products in each category, right? So in that case, you can go for count of this over this, right? So count, so these are the, these group functions, we know how they work, right? So max, minimum, sum, count, average, and all. Then the other 5 functions are specific to window functions. You can't use it in any other scenario, right? Give me a moment.
Yeah.
Sorry. Right. So now let us look at rank, dense rank, row number, right? I don't know if you're in your table you have over. Yeah, this is also fine, right? Deepak, this is fine. Okay, so I maybe you don't have it, but in my database there is a table called marks, right? If you say select star from marks, this is what I have, right? So now if you think of it as a class, right? And I want to give rank to people, right? Who gets the first rank here? How will we give ranks here in this class? Who gets the first rank?
One who scores highest mark.
Yeah. So in this example, John gets the first rank. Tom and Tim both should get second rank, right? Jim and Pat should get third rank, and Pam should get fourth rank. So this is how in a class we will do ranking. So to do this, what we have to do, we have to arrange the records, right? So we have to order the records based on marks in descending order, right? So that 73 is at the top. Then you have 67, two people getting 67, then 45, 45, and then 33, right? So this is what we need. So what we need to do is, within the window, we will order by marks and descending. And from this, we will select the rank, right? So let us try this. Select name, mark, then rank over. So now we don't have to do any partitioning, right? So we don't have to do any grouping. Instead, what we have to do is we have to order, right? So we will order by mark descending as R and K, right? So from marks, okay? Let us see what we get. Did we get what we want?
Yes.
Yes. But this is not how we will give ranks, no? If you see John has got first rank, that is fine. Tim and Tom have got second rank. How about Jim and Pat? Don't we want to give them third rank?
Yes.
But
Fourth.
what we have here, 4 is given. Then here you see 6th rank, right? So that is because a rank will just take the next value. So according to this ordering, this is 1, right? So 2 and 3. So, but 2 and 3 have been given the same rank. But the next one, it will take us 4 only, right? So 4 and 5 have been given the 4th rank. And then the 6th will be given 6 and so on, right? What if you have 3 people with 67? Let's say Jim also has 67. Then how will rank work? What if Jim also has 67?
He will get second rank.
He'll get second rank. What will Pat get?
Third rank.
5 and 6. Fifth rank.
Fifth rank. No,
Fifth rank.
this will be 5 and 6. So this is what rank will do, right? So if you are going for rank, you see there are gaps in the rank, right? This may not be very helpful for us. So instead, what we want is something like this. We want 1, 2, 2, 3, 3, and 4. So if you don't want any gaps in the rank, you go for dense rank, right? So instead of this, you will just say dense underscore rank. So now, is it fine? We get what we wanted, right? Tim and Tom have second rank, Jim and Pat have third rank, and Pam has the fourth rank. Okay. Is the difference clear between rank and dense?
Yes, ma'am.
Okay, so now that you have this ranking, right? So the most common question that is asked in any interview is to find, for example, find the person who gets the nth highest salary, right? Find the person who's getting the third highest salary, or find the person who's getting the fifth lowest salary, or that is kind of a common question that is asked in all interviews, right? Can we use rank to find it? So if I ask you, who is the person who is getting the third highest mark, what would you say?
Jim and Pat have
Jim and Pat.
Jim and Pat have the third highest rank, right? So you can't just order it in descending order and take the third record. That will not work, right? Because if you do that, then we will say Tim is the one who's getting the third highest. But actually it is Jim, and there are 2 people who get the third highest rank. How can you find that person? Again, assume this is a table. If you have a table like this, can you find the person with the third highest rank? Can you find?
Where rank is equals to 3.
Yeah, where rank is equal to 3, right? Treat this as a table and select from this table where rank is equal to 3. So it becomes easy to find any position they ask. If they ask for 7th highest salary, right? Or the 6th highest salary, it doesn't matter, right? We will just write this, and then wherever rank is equal to 7, how many ever records are there, it will select and it will give it to us. Okay. So can you write this? Find the employee, right? Find the employee who gets the third highest salary. Write this, who gets the third highest salary. Yeah, Deepak, why you have to write it 2 times? I think you were trying out, maybe. Right, only the second part is needed, right? So select star from, select first name, last name from something, right? Yeah, order by salary descent. This is just for reference. The first query is for reference, so that we see from what we are selecting, right? And then select from that. Okay, so shall we write it, the other people? What we have to do? We have to select, or let us say with E as select star, comma, what did we want? I forgot. Other highest salary from and then dense rank, over order by salary descending. Yeah, that is correct, Vishal. This cough is killing me. Okay, salary descending as R and K. Right. From my EMP. Select star from E, where E dot R and K is equal to 3. Right, so this is the person who's getting the third highest salary. Let us see if that is correct. Right, so select star from my EMP, order by salary descending. Right, and let's limit it to 10 records. What did I do?
Spelling, ma'am, salary.
Okay. Right, so it has given us this record. Right, so now it doesn't matter which record they ask for, right? So 5th highest or 6th lowest. So whichever they ask, you will be able to find. Only thing is you just have to say rank is equal to so much, right? So this is one of the most common questions that is asked in interviews. All right. So this is your rank and dense rank, right? So now we have used partition by separately. We have used order by separately in the window, right? But we can use both together. So if you use both together, right? So what will happen is it will first group the records, and then within the group, it will order based on what you're saying. So here we have given the third highest salary, right? What if I want to find the third highest salary in each department? Right? In each department, who's the person getting the third highest salary? So what will I have over the window? we will say over a dense rank over, right? First, I will partition by department ID. And then within that, we will order by salary descending. So it will have departments here. And then here it will order based on descending order of salary, right? So when you say dense rank over this, right? So this will be ordered based on the salary they are getting. And you will select the person who's getting the third highest salary in each department. Can you try this? Write the inner query first, right? And see what you're getting, and then you can select. Did you try? Yeah, Rani, you are right. Prabhat, you have written the first part, right? And from that, you have to select all the records where rank is equal to 3, right? So let's just try this. We will say select star from star, and then dense rank over partition by department ID, order by salary descending as RNK from my EMP. Let us limit it to some 20 records and see what we get, right? So not every department has, this department doesn't have 3 people, right? So you don't have a rank 3, but from this, we just have to select those records where RNK is equal to 3, right? So within this department, this is the person who's getting the third highest salary, right? Within this department, department 50, this is the person who's getting the third highest salary, right? So with CT as this, with CT as this, select select star from CT where R and K is equal to 3. Right, so these many departments have more than 3 people. Looks like, right. So this is how you can find the highest nth highest value, right, or the lowest value also. So if you are given questions like this, will you be able to find it? Will you be able to write queries like this?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Just visualize it in 2 stages, right? And then from the smaller table, think of you're selecting from the other one. Okay. So maybe we can take, should we take a break? Before we take a break, let us do one more thing, right? So I have, you can think about it and then we can come back and do it. So you have a table called sales, right? Where you have the name of the employee, the year, right? And how much the sales they have made in each year, right? So what we want is, we want to have a leaderboard kind of a thing, right? Where we want to know in each year, who was the first, second, and third, right? If you see in 2016, if you look at 2016 records, who has the highest sale? John has the highest sale. And then Alice, and then Bob, right? So this is the leaderboard in 2016. In 2017, who was the highest? Two people, right? John and Bob. So John and Bob have the first place and Alice has the second place. And in 2018, 200, 200, 250. So John has the highest place. Okay, John always is the top. John, and then Alice and Bob have the same place. Alice and Bob have the same place. So this is what I want to see, right? Can you write a query to do this? Yeah, Rani, you're right. Yeah, Deepak, that is also correct. Right, so all you have to do is first partition by year, and within that order by sales in the descending order, right? So select, so most of you have got it. Select star and dense rank over partition by fiscal year, order by order by sale descending as RNK from sales. Right, so this is what we wanted. Yeah. Right, so you can see all complex things you can easily write if you understand how the window functions work. Right. Yeah, hi. So now let us look at the last window function, right, which is lead. Lead and lag are similar. So lead, right, you have to say which column and some number, right, over whatever window you are creating. Similarly, lag also, which column, what level of lag over some window, right? So this is how you will write your lead and lag. You need to give the column name, right? So in your example, in your table, so what is lead and lag? So normally what happens is when you have time related data, right? It need not be time related, but mostly it is used in time related data. So you have time and let's say the stock price, right? So in January of 2020, the stock price was some 150. In Feb 2020, it went to 49.3. Then March 2020, it went up to 151.2. Then April 2020, it went to 150.75 and so on, right? So this is what we mean by time series data or time-based data. So what lead and lag will do is, let us say I want to see as I go from January to February, right? Did I make a gain or did I make a loss on this particular stock? Did we make a gain or a loss as we went to Jan to Feb?
Loss.
How do we know that? I need this. I also need this, right? If I have these two side by side, I can say when I go from Jan to Feb, I made a loss. If I want to know whether I made a loss when I went from February to March, I need this value and 151 side by side, right? So if I can have this 149.3 here, if I can have this 151.2 here, and this 150.75 here, can I easily find out whether there is a gain or a loss? Right? I can just subtract these two columns. If I have a positive value, it is a gain. If I have a negative value, sorry, if you have a positive, it is a loss. If you have a negative, then it is a gain. Can we say this? Yes.
Yes, ma'am.
Yeah. So here, this is what I mean by the lead value. For each record, if I take the lead of stock price, comma 1, it will get me the next record, the value for that column from the next record. Right? So this 149 will come here. For each record, lead of stock price, comma 1 will give you the value of stock price from the next records. For this record, lead of stock price, comma 1 will be 150.75 and so on. Right? So that is why we have to specify the column name. There might be multiple columns, right? Which value do I want? So I want to take the next value of the stock price column, right? So this is lead. What will be lag? Can you guess what is lag of stock price?
Comparing with previous month.
Comparing with previous record, right? So this, for the first record, there is no previous record. So this will be null. For the second record, the lag of stock price by 1 was 150. For the third record, the lag of stock price by 1 was 149.3. For this record, where am I? Here, no? So 150, for this record, the lag of this, right? So that is one record before that. So that is 151.2. So lead will get you the next values. Lag will give you the previous values. What if I say lag of lead of this comma 2? In that case, instead of taking the next value, it will take the second next value. Right? Instead of taking this, it will take this value. It will skip 1 and 151.2 will be taken. What if I lead of 3? What is lead of 3 for the first record?
150.75.
150.75, right? So this is your lead and lag. So now that we know this, you have a table called trains. Select star from trains. Right, so you have two trains here. Train 1 is 110. Train 2 is 120, right? So what I want to know is, what is the journey time from this station to this station? What is the journey time from this station to this station, right? If I want to know the journey time, what should I do first? How much time does it take to go from San Francisco to Redwood City?
54 minutes.
How do I know that? As a first step, I should have this here. Right? I should have this here. 11:02:00. And I should have this here. 12:35:00. And this doesn't have anything. So this will be the last term, null. So if I have this from this table, I can just subtract these two, right? Or subtract this from this. So that will give me 54 minutes. For this, I will subtract this, this from this. So that will give me how much? 8 minutes or something. Right? So as a first step, what I want to do is, if I want to take this and put it here, what should I write here? How can I select this and put it here?
Lead time, comma 1.
Lead of time, comma 1, right? But then we have to decide what goes into the partition. Sorry, what goes into the window. What goes into the window? Do we need partition?
Yes, partition by train ID.
Yeah. If you don't partition, then you will end up mixing up the trains, right? So we will partition by train ID and then order by time, right? We have to make sure this is correctly ordered. And then I will take the lead time, right? Once I get this table, I will select this, and the difference between this and this as the journey time. Let's write the first step first, right? So let's say select star, comma, lead of time, comma 1 over partition by train ID, order, no comma here, order by time as next time from trains, right? So we are halfway there. Now all we have to do is with CT as this one. I forgot, I always forget this comma. With CT as this, right? Select star, comma. Now what should I select? How do I get journey time?
Time minus next time.
So you can't directly do minus because it is a time function, right? So what we have to use is we have to say sub time, right? So sub time is a function that is available. If you search the date time functions, you will see how to subtract times, right? So I can say sub time of next underscore time, comma, time as journey time from city. Right, so can you see now? Or journey time, journey time, whatever. To go from here to here, we need 54 minutes. Here we need 8 minutes. This is 1.5 hours, right? Here 1 hour 49 minutes. This is 41 minutes. So we get the journey time, right? So mostly if you see companies like Uber and people who work in logistics and all, they use this and they use this to find the shortest route to a particular place. Okay. Now, using this, right? Try to solve this question, which was an actual interview question given to one of our students. Select star from, I think you have a table called students underscore D, right? So what we have here is the date, right? And these are the students who were present. Student 1 was present, 2 was present, and 4 was present. 3 was absent. On 15th, if you see, 1 was present, 2 was present, 3 was absent, 4 was present. So what was asked is find those students who were present for 3 consecutive days. Right? Find those students who were present for 3 consecutive days. Can you think about it and how you will solve it? No need for the query. Just normally, right? How would you solve this? Always think of how you will manually solve it, right? And then you will get the query to write. How will you find which students were present 3 days in a row?
First, we have to partition by student ID, and then we have to check, we need to check consecutive days.
Right. So we will partition by student ID. Then do we need to order?
Yes, order by date ID.
Order by date, right? So we will take the student ID, right? Order by date 14, 15, 16, 17, right? And then we have to check the attendance. If this is how it is, was the student present 3 consecutive days?
Yes.
How do we know? We
For
looked at this record. We looked at this record. Both are present, right? So how can we write the query now? Others, do you agree with this thing? Where we are partitioning by
Yes, ma'am.
student ID, right? And order by date. So this is called attendance. So can I take the lead of attendance by 1 and put it here? Right? For this record, I will take the lead of attendance by 1 and put it here. Then for the same record, I'll take the lead of attendance 2 and put it here. Right? Let me do that. And then you tell me what is the additional next step that we have to do. So we will select star, comma, lead of attendance, comma 1 over partition by student ID, order by date. As day 1, day 2, comma, the same thing, right? Lead of attendance. I could have lead of attendance, comma 2 as day 3, let us say. From students underscore D. What did I do? Unknown column.
It's date ID.
ID.
Okay. Now, which record should I select? Can I select all records where attendance is P, day 2 is P, and day 3 is P?
Yes, ma'am.
Right.
Yes.
So those are the students who are present for 3 consecutive days. Right. So we will say with CTE as this. With CTE as select. I just want the student, right? So select student ID from CT where attendance is equal to P and day 2 is equal to P and day 3 is equal to P. Right. So this is, so we are getting duplicate records. So we don't want that. So instead we can just say select distinct student ID. Right. So those are the student. We don't want to see student 1 and 1. So select distinct. So student 1, 2, and 4 were present for 3 consecutive days. Student 3 was absent. Right? He was not there for 3 days. He was there for only 1 day. Right? So visualize it first. Think of it as a separate table. Right? And then you can select from that. Okay. So if at all you are asked questions like this, even if you don't remember the syntax, just walk them through the logic, right? So like you just said, you will say we will group it based on student ID, then order it based on the date. And then we will take the use the lead function to get the next records. And wherever we have 3 consecutive P values, that is the one that we will select, right? So this concludes all the major topics in MySQL. So so let me quickly tell you about subqueries also, right? But the thing is, subqueries used to be quite commonly used earlier, but now with the availability of window functions and joins and all, subqueries are not really, actually when you write subqueries, they are very slow, right? When you execute subqueries, they are extremely slow. So you will see that whatever you can do with the subquery, you can do with joins also. Either using joins or window functions, you will be able to write the same thing, right? And it will be much faster. But just to be aware of what a subquery is, a subquery is where you have a query within a query. right? For example, we just solved one question, right? So where we said, find the person who's getting the maximum salary in the company. How will you write, forget window functions and all, right? If you don't have that, keep aside window functions. So if you want to find the person who gets the maximum salary in the company, how will you write this? How will you find the person who gets the maximum salary? First of all, you should know what is the maximum salary, right? If you know what is the maximum salary, then you can select from MyEMP wherever the salary is equal to maximum salary, right? So I can say select max of salary from MyEMP. So this is the maximum salary, right? So now what I want is find the person star from MyEMP where salary is equal to this 24,000. But how did I get the 24,000? I executed this query, right? So where salary is equal to, if I execute this query,
Ma'am, salary spelling.
right? So Stephen King is the person who's getting the highest salary. So this is what we mean by a subquery, right? So let me just yeah. So this is called a subquery. This is a query within a query. You can call the subquery or inner query. This is the main query or the outer query. So always the inner query is executed first, right? The inner query is executed. The result of that is substituted here, right? And based on that, the outer query will be selected. So what you see here is called a single value subquery, because the subquery has returned only one value, right? Sometimes your subqueries can return multiple values. So if you take an example here, right? If you look at your database, there is a table called employees, I think. Okay. Let us limit it to some 10 records. Then you have a table called offices. Right. Now, if I ask you to find all employees who work in USA, how will you find it? How will you find all people who work in US? Don't think in terms of query. Normally,
Ma'am, by joining the table.
yeah, the best way to do this is to join the table, right? So that is the ideal way to write it. You have office code here and you have office code here. So you can join the tables based on office code, right? And then select all the records where country is equal to USA. That is the best way to do, right? So, but you can also write a subquery. So what I can do is I can find all the office code corresponding to country is equal to USA. Right? So I can just say select office code from offices where country is equal to USA. This will give me 1, 2, and 3. Now I can just select from employees where office code in 1, 2, and 3. This will give me the people who are working in USA, right? So this is what we mean by a multiple value subquery. So like I said, it's better to write a join, right? But there is also a subquery that you can write. You can say first select, what is that? Office code. Office code from offices where country is equal to USA. So you get office code 1, 2, and 3, right? So now all we have to do is select star from employees, select star from employees where office code in, right? In what? Office code in 1, 2, or 3. But then how did I get this 1, 2, or 3? I had to write a subquery, right? So I'll just say select office code where country is equal to USA. Right. So these are the people who work in USA. So this is the inner query. Will be executed first. So you get 1, 2, and 3. So select star from employees where office code in 1, 2, and 3. Right. So this is called multi-valued subquery because the subquery is returning more than one row. But usually only one column should be selected so that you can say where office code in this one. Right. But there is always a way to write a subquery better. Instead, you can go for joins or some other condition, right? Either write window functions or write joins. Always avoid subqueries when you're writing queries because joins are close to 100 times faster than a subquery, right? So unless you don't have any other choice, it's better to avoid subqueries. Okay. So I think that concludes our MySQL sessions. Do something, go through your, what is that, your assignments over the weekend. If you need anything, right, if you need anything additional, or if you need any clarification or something, we can see if we can arrange for a session. Right. Yeah, you wanted to say something?
Ma'am, how can we save the file? Because we need to send to the assignment team, right? So I have saved, but the only script gets saved.
Only script will get saved. If you are using the, what is that, your workbench, you take a screenshot and paste it.
Okay.
For each query, or if you are using the command line, you can just do a copy of this and then put it in the workbench, put it in a WordPad and send it. Right, so that will be
Okay,
a
ma'am.
Yeah. The stored procedures, you can just save it as a .SQL file and you can send it to them. Okay. Yeah, normalizations actually, it is a way of designing your tables, right? It's not, just a moment, let me see if I can search for normalization, right? Yeah, it's a slightly, yeah, advanced topic. So basically it tells you how to organize data in your database or how to create a table. Okay, I think this should be good enough. How to create tables, right? So when we created the students table, we said we said we cannot create something like student ID, student name, age, course, then what, duration, then fee, right? If you design something like this, what happens if there are 1,000 students taking MySQL, right? So for 1,000 people, we will end up saying MySQL 2 weeks and $100 fee. So this is what we mean by data redundancy, right? So we unnecessarily are storing redundant data over and over again, right? So this should be moved out into a separate table. So normalization, there are basically you will look at 3 normal forms, right? So the first normal form will be, I just opened a page. I think this seems good enough, right? This is the process of organizing data in the database. So it basically tells you how to create tables, how to form relationships between them, right? So the thing is, as a data analyst, you will not be expected to design tables and all. Mainly, you will be expected to select records, right? It's the select queries that we should be focusing on. But just to give you an idea, if a database is in the first normal form, then all tables, you should make sure that you have eliminated all the repeating groups, right? Repeating groups in the sense something like this. You should make sure that they are moved to a separate table, right? And we should make sure that every record can be identified with a primary key. Right? We have talked about this, but we didn't think of it in first normal form, second normal form and all, right? The second normal form is where you convert data, connect the data with the primary key and foreign key, right? And the third normal form is this is where we say anything that is not relevant to that entity, right? If you have the students table, I am identifying each student with a student ID, right? Anything that is not dependent on this student ID column, you should remove it and put it in a different table. It'll all come down to the same thing, that we are avoiding the redundancies, right? We are moving this. So anything that cannot be identified by the student ID, see this 10 does not identify this. It identifies this particular student, right? So the thing is, if you do too much normalization, then also it becomes very complicated, right? For example, they have given an example here, right? If you put address in a different table, if you put the list of university in a different table, you put course in a different table, you put department in a different table. If I want to get the detail about one student, I will have to connect to so many other tables. Only then I will be able to get so I have to join to 5-6 tables to get details about one student, which will make it very complicated, right? So the idea is to have just the right amount of normalization when you are designing a table. So like I said, we don't have to go too much into normalization examples, because this is for a person who is designing tables for an application, right? But here they have given an example. If you want, you can check it out. So this is an unnormalized table, right? So when you convert it into first normal form, see, these things will be separated into separate records, right? It's not a topic that we can cover in a short duration, but hopefully you have got an idea about what we mean by normalizing. Basically, taking the data that you have, separating it into different tables, so that finally what we want is We want each table to represent an entity and only the characteristics of that entity. So if you have a table called students, this should have only the properties of students. And each student should be identified by a primary key. Right? If at all the student is taking a course, the course details should go into a separate table, and then you should only give reference to the course from the student table. Right? So this is what your normalizing is all about. How do we design the table so that we avoid repeating data, right? And we separate data into different tables, and how we define the connections between different entities, right? This is a slightly complex topic, right? So let's not go too much into depth about it. But this is the basic idea, right? So if you see that you have done too much normalization and you have split it into many, many tables, sometimes you will have to do a denormalization. We are okay with some amount of redundancy because we want to avoid connecting to multiple tables to get data, right? I don't want a big join. So I'm okay to denormalize a little bit. Some redundancy will be there, but for my purpose, it becomes easy for me to access records. So it's very dependent on how you design tables, right? I think this seems a simple example, right? You can go through, but it's a slightly complex idea. How can we export SQL data in order to work on it using Excel and Power BI? I am not an expert in Excel and Power BI, but as far as I know, in Power BI that there is an option to import from some external source or something. Right, when you're opening Power BI, I think they give you an option from external source. There you can specify all multiple sources will be specified there, from Excel, from SQL, from PostgreSQL, which database you want to take it. Right, it is there in Power BI. Excel, I'm not sure. But you can export your data. If you go to your workbench, any table you want, you can export it into a CSV file and you can open it as Excel. Right, in our demo DB, let's say we have the authors table, right? You can right click here. There is a data export wizard, export, right? Both columns you want to export. And here, so do you want to export it as a CSV file or a JSON file? So we have said CSV. Field separator, if you want it as a comma, you can select that. That should be enough. Next, table data export, what export to local machine.
The path, file path.
Oh, I didn't specify. Let's say onto my desktop, I'll call it authors. Right. So next 9 records are exported. And if you go to the desktop, authors.csv is there. You can open it with your Excel. Right. Similarly, if you have a CSV file, you can import it. You can import it and create a table based on that. So, yeah, so this is how you can export into an Excel. But how to connect from Excel to a database, I don't know. I don't work with these tools and all, Power BI, all those I don't use. Okay. All right. So maybe you can see you have something called get external data from database. So probably you will have to check that out, right? Excel cannot complete here. You need the ODBC driver and all. So yeah, you can probably look it up in some YouTube or something. Okay. Anything else?